Hey there, Pre-Calc kids. Today we're looking at 2.4, exponential function manipulation. First thing we gotta do is look at some properties and see if you recall them. You guys remember that if I take the product of two numbers and take it to a power, that power goes to each. That's a to the m times b to the m. A power to a power, you multiply your powers. A power times a power, you add them. You never do the same operation twice. So here we're exponent to exponent, so we multiply. That's different. Here we're multiplying, so we add different operations. Okay. Also, don't forget that b to the 1 over k is the k root of b. So like square root of 5 is actually 5 to the 1/2. Negative exponent moves it to the bottom. And fractions, you distribute it. Okay. So I went through that pretty quick, but this should be a review. If you don't know it, that's fine. Ask questions, look it up. So let's do this. Evaluate each number to 3 decimal places. If I were you, if I were you, I'd be a student. Jiminy Crickets, if I were you, I'd know how to use this. If I were you, I'd plug these in my calculator and see if I get the same thing that I'm getting. So 5 to the 2.3, I got 40.516. 3 to the square root of 7, I got 18.295. And 6 to the negative 1/2, that's going to be a decimal because that's a negative exponent, makes it smaller, is 0.068. Okay? So relatively rapid fire, but you guys try it too. Make sure you know what you're doing. If you're getting something different, let me know. I'll help you out maybe. All right, let's talk about some characteristics of exponentials. Okay, the domain is going to be all real numbers. We can plug in anything to our exponentials, and we've looked at that before. The range is going to be all real positive numbers because we can't get a negative from it, okay? Because there's no initial point. They're all going to pass through 0, 1. Again, this is without an a, without an initial value. So the y-intercept is going to be 1. If b is greater than 1, it's going to be increasing and concave up. If b is between 0 and 1, it's decreasing and concave up. Okay? And we've seen this before. If it's increasing, it looks like that. The other one looks like this. Okay? They're both concave up. The graph will approach but not cross the x-axis, making that the asymptote, or y equals 0. It's also a 1-to-1 and inversible. 1-to-1 means it passes the horizontal line test. Uh-oh. We'll talk about that more when we do inverses, which is coming up with logs. All right, so let's do it. Let's graph 2 to the x and 1/2 to the x, and what can we conclude? All right, so we're going to do a quick and dirty sketch here. So we'll do 2 to the x in green. So we know it's going to pass through the point 1, 0, or 0, 1. Let's plug in some points. What's 2 to the first power? 2. 2 squared is 4. 2 to the third is 8. If you want to do 2 to the fourth is 16. 2 to the negative 1. Remember, 2 to the negative 1 would be 1/2, right? All right, that should be enough to graph it. Good enough. So that's my 2 to the x. 1/2 to the x. Now this one is going to be the exact same, but mirrored on the back side. Because it's the exact same function, just flipped, right? Let's see how good I can do, if I can do better. All right, we'll count it. All right. What can I conclude? Well, they're the same graph. But reflected over y-axis. Okay, which makes sense because y equals 1/2 to the x is the same thing as y equals 2 to the negative x, right? Because if I make it a negative exponent, I reciprocate it, I flip it. And these are the same with a negative, and if you guys recall from Algebra 2, putting a negative by your x flips it over the y-axis. All right? Okay. All right, that's not so bad. Eep. A lot of reading here, but I'll help you through it. I'll read you through it. This is a lot of review. If we are looking at the base function to the x, a vertical shift or translation, and we did this last unit too, but we're going to do it again because it's important stuff. If I add or subtract, I'm going to move it up or down, and that's outside the parentheses, right? Outside the function. Now for a horizontal translation, that's when it's next to the x, in parentheses usually, or implied parentheses. So do you see how the x minus 3, the minus 3 is by the x, not on the back side. And remember, it's opposite what you think it's going to do. So minus 3 is going to go to the right 3, plus 6 goes left 6. Okay? Vertical dilation, that's again if the number's in front of your exponent. This is kind of like your initial value, your a. Remember how we did a times b of x? It's the reason why we chose a. It's like out here we have a 3 in front. Stretch a 3. Here we have a 1/2. Shrink by 1/2. Because remember, vertical stuff is what it is. If I'm adding, I'm going up. Multiplying by a number bigger than 1, it's getting bigger. Okay? Horizontal dilation, remember this one is a factor of 1 over a. So we have to take the reciprocal of what's by the x. So if it's 1/4 x, that's actually a stretch of 4. And if it's 3x, it's a shrink of 1/3. It's 1 over the number in front of your x. And lastly, if we put a negative in front of our f of x, we put a negative in front, we're flipping over the x-axis, the line y equals 0. If we put it by the x, we're reflecting across the y, like our example 2 was. Okay? All right, let's see if that works. Let's test it out. So I see that this is 3 to the x plus 2. So I know I'm going to be shifting it left 2. But let's prove it. Let's prove it. So I'm going to go through and do my chart. 3 to the negative 2 is 1 over 9. Right? Over here it's going to be 3 to the negative 2 plus 2. 3 is 0, which is 1, right? 3 to the negative 1 is 1/3. 3 to the negative 1 plus 2 is 3. Right? You guys believe me? You see what we're doing? 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. Okay? So over here, 3 to the second is 9. 3 to the third is 27. And 3 to the fourth is 81. Uh-oh, it looks like we did it. So let's graph f of x in green. So we have -2, 1/9, 1/3, 1, 3, 9. Oh my gosh, I'm struggling today. All right. And we'll graph the g of x in red. Am I going to use Christmas colors all season? Probably not. It just so happens I am right now. So we're going to go -2 is at 1. -1 is at 3. And this one's at 9. Oh my gosh, it's the same graph. Kind of the same graph. Just shifted to the left too. It works, guys. It works. Y'all don't believe me. Y'all hating on me, but I kind of know what I'm doing once in a while. All right, let's do another one. These will get exponentially more difficult. All right. All right. So they're asking, can we rewrite the function 3 to the x plus 2 in the form of h of x equals a times bx using the transformation properties in the table? Describe the transformation of the y-intercept, and let's figure it out. Okay. So our g of x is 3 to the x plus 2, right? And we need to transform that so it looks different. Now, if I'm adding my powers up here, what does that mean? It means I was multiplying down here, right? And if I look at my properties from the first page, remember that, was it a to the x times a to the 3 would be equal to a to the 3x, right? Now, what's 3 squared? It's 9. 9 times 3 to the x. So wait a second. I just rewrote this function as my h of x, which they wanted. It's equal to 9 times 3 to the x. We did it. So are these the same function? They actually are the same function. Isn't that wild? So shifting it can be the same as like a vertical stretch. Weird, right? All right. So let's talk about what happened to our intercept, right? Or let's see how it actually changes my my equation, either which way. So g of x, they want us to describe it, is a shift left 2, right? So the y-intercept, they want to know what happens to the point, the y-intercept. The y-intercept was 0, 1 is going to be shifted to -2, 1, right? Because we shifted it to left 2. H of x is what? Would be a vertical stretch of 9. So the y-intercept would go from 0, 1 to the point 0, 9, because I'm multiplying my y value by 9. And that makes sense, because then if I graph this beast, you know, I have -2, a1, and it's going to go up through 9. That's different than when it went through 1. We're moving it to the left 2 either way. Isn't that wild? I don't know. I think it is. I hope you enjoyed. Have a good day.